Let's begin with an overview of the current MSPM0 microcontroller portfolio. As a whole, the MSPM0 portfolio extends from 8 KB to 512 KB of flash and 8 pins to 100 pins. Within the portfolio, there are 4 key device families: M0C, M0H, M0L, and M0G. M0C stands for our entry-level and low-cost device family, offering 32-bit performance at 8-bit prices. These devices range from 4 to 64 KB of flash and 8 to 48 pins. These devices also offer the world's smallest microcontroller package, going from 1.38 millimeters squared in a die-size ball grid array. Then taking a step up, we have our MSPM0H family. These devices are our high voltage device family with 5-volt supply voltage, allowing for improved signal-to-noise ratio and 5-volt sensor compatibility. These devices range from 32 to 64 KB of flash and 20 to 48 pins. Then one more step up, we have our MSPM0L device family. These, while our whole portfolio is low power, these devices are optimized specifically for low power applications. Perfect for battery constrained and power constrained projects. These devices offer 71 microamps per megahertz in run mode and 1 microamp with retention in standby at 25 degrees Celsius. These devices have a very wide range from 16 to 256 KB of flash and 16 all the way up to 80 pins. Lastly, we have our MSPM0G device family. These devices have the highest compute, adding not only a faster CPU frequency going up to 80 megahertz, they also have dual simultaneous sampling ADCs, as well as hardware accelerators, both for math performance and for cybersecurity. All the families are hardware and software pin-to-pin compatible, allowing you to move up and down to best fit your application needs with ease. As briefly mentioned earlier, the ARM Cortex-M0 Plus microcontrollers can be used in a variety of applications. The main differentiator is the application firmware. The same microcontroller could act as an I/O expander, communicate an ADC reading over various communication protocols, read and process a thermistor temperature, and also control motors. The only thing that would change would be the code, proving how flexible and valuable software can be. Traditional code development is typically an involved process that is ideal for experienced developers or those with resources to learn a new environment. The software engineer would work with their choice of integrated development environment, and TI offers Code Composer Studio for free as an option, or they can use other third-party IDEs such as IAR or Kyle. Then they would parse through the MSPM0 Software Development Kit, SDK, to use as a reference to build their application code. The SDK includes driver libraries for that added abstraction, middleware, stacks, example code, and everything that can be used as a base for further development. To help with the process, there are various graphical tools, including Analog Configurator and System Configurator. Analog Configurator allows users to drag and drop their analog components to visualize their analog signal chain. System Configurator, on the other hand, allows users to select the peripherals they want in their design, assign them pins, and generate the configuration code. After the configuration is complete, the software engineer builds the application code off of the base generated by these tools. As a whole, traditional code development offers a lot of flexibility, but can be more involved and time-consuming than ideal. This is where MSP Zero Code Studio comes into play. MSP Zero Code Studio is a visual design environment that simplifies firmware development, making it possible to configure, develop, and run microcontroller applications in minutes with zero coding and no IDE required. This tool allows the user to drag, drop, and connect blocks corresponding to digital, analog, serial communication, and data processing actions for the microcontroller. The tool translates the block flowchart to usable application code, handling interrupt management, peripheral configuration, and methods for moving the data for you. Then you are able to flash your code directly to your MSPM0 device of choice. No need to download a separate IDE. With the cloud version, you won't need to download anything onto your computer to get started. We are continuously adding new blocks and features to the studio as our MSPM0 portfolio is growing in parallel. This tool offers device peripheral blocks such as PWM control, GPIOs, different communication interfaces like UART, SPI, I2C. There are also blocks for conventional logic concepts such as and, compare, if else, or, and more. There are also options to add different loops and variables into the sandbox as well, as shown on the right. As mentioned earlier, this resource allows engineers to quickly evaluate MSPM0 devices, program without software experience, and create prototypes and simple designs in minutes. Zero Code Studio is an easy-to-use interface that greatly reduces onboarding time and reliance on documentation. Using the building blocks previously mentioned on the slide before, you can create analog subsystems, communication bridges, and even motor control algorithms without having to write a single line of code. Next, we will dive into 3 different real-life examples of using Zero Code Studio. First, we have our temperature sensor. In this case, the microcontroller is reading in an ADC signal from the pressure sensor and then processing the information and transferring it via I2C to the host microcontroller or processor. To use Zero Code for this application, it would just take 2 blocks. So we would have the ADC read on the pin selected for the temperature transmitter, and then the I2C target set up as well too. Next, we have the coffee machine. In this case, the microcontroller is being used to process the human-machine interface, read in a button press, and then once again process and send via I2C to the host microcontroller. So in this case, instead of the ADC read block, it is switched to on button press. So here we're able to continuously check this button with the GPIO in this infinite loop and make sure that we are catching as soon as it is pressed. Perfect for any sort of human-machine interface. Okay. Next, we have the electronic smart lock. In this case, the microcontroller is reading in the button press again through the GPIO in order to tell once it is pressed by the lock. And then instead of processing and communicating up to the host microcontroller or processor, this time the M0 itself is the one who generates the pulse width modulation to send to the motor driver, the DRV8214, to help move the motor and unlock the device. In this case, there are 4 blocks that are required to achieve this. First is the initial block for initializing the PWM, and then there are 3 within the infinite loop. The on button press, as previously seen, the PWM start, and the SPI controller transfer in order to communicate to the DRV device. Next, we will get into the details of how to use the Studio. The process can be split into 3 simple buckets: start, develop, and load. On the start side of things, all you have to do is click on the device that you want to use. Say you want to start with our Launchpad MSPM0L1306. Then you would just have to click it in the dropdown. Then next, you start either a new project or load an existing project. TI also provides multiple examples as well to use as a base. Then on the development side, as previously mentioned, you can add, remove, and configure blocks in order to develop the flow that you are looking to in your application code. And you can also use that to view the generated C files as well as the pinmux and pin usage. Lastly, then when you are ready to build, you can either click Just Build or Build and Load. Then in order to save, you can click on the File tab and save the project file, or just save the .out executable. In the next portion of this webinar, we will walk through 3 example demos to showcase the functionality of MSP Zero Code Studio. The first one is an LED toggle. Next, we'll take a step up and go through the conditional logic example. And lastly, we will take a look at a motor control example with our MSPM0 devices. First, let's take a look at the basic LED toggle. This example will walk through how to add and connect blocks, also how to toggle the Launchpad's onboard LED every time the Launchpad button is pressed. This involves 3 different steps. First is adding the blocks, next is connecting the blocks, and third is assigning and configuring the blocks as well. On the add block side, you have to highlight the infinite loop in order to add blocks inside of it. This is one step that I really wanted to make sure to highlight. So you click on that, and then click on the far left. You can add in the 3 blocks that are necessary for this case. First is the on button press. Then you will add in a delay block as well, and an LED toggle block. The next step is making connections. Going from the start button on the left side of the infinite loop, you will then connect to the previous port on the unbutton press block. This is called a sequence connection, and it allows you to specify in which order blocks will be executed. Then you can connect from that to the delay, and then also to the LED toggle to the end of the infinite loop. In this infinite loop, it'll be run continuously in the order that it has been connected. The last step here for this entry example is configuring each of the blocks. As you can see, when you click into a block, there are specific configurations that are made available to you. Very similar to the sysconfig tool that we mentioned earlier, you can select the configuration, the pin you want the block on, as well as different speeds, different variables, everything there. So in this case, for the basic LED example, we will select the delay block on the design and then set the delay parameter to 500 milliseconds. This will add a brief delay to the LED toggle action after the initial button press. Then you can also select the on button press in order to configure it for PA18, which is the button on the launch pad. Same can be done for the LED toggle, configuring it to PB22. Then the last step here is to build your program and load it onto the Launchpad. In this case, like mentioned earlier, you just select build and load and wait until the program is done building. Then you can follow the on-screen prompts to load to the connected device. And in just a couple minutes, you have successfully developed your first Zero Code Studio program. Next, we will take it one step further with the conditional logic example. For this example, we will configure 2 different variables, variable A and variable B. Variable B will be the threshold here, and variable A will be determined by the controller and the user. So in this case, if the user presses one of the Launchpad buttons, the value is increased. And then if the user presses a different button, PA21, the value is decreased. This just helps to showcase the logistics behind the conditional logic and the functionality that we can provide here with MSP Zero Code Studio. In this particular example, it is easiest to begin with a pre-built example code for the conditional logic. Here, if we use if/else UR output as the source, this will allow you to use this base example showcasing the compare functionality. In this case, it is just if A is greater than B, A is reset to 0. Otherwise, A is increased by 1. So this will just help with the overall understanding of conditional logic in this case. We will modify this example such that the input A is controlled by the user, and so that the onboard LEDs change based on the comparison. Next step here is to configure the buttons. In this case, we'll be making 3 different infinite loops. 1 to increase on a button press, 1 to decrease on the button press, and then the third one to check what the difference between the variables. So here you would just have to click add an infinite loop, connect the on button press block, and select the PA18 option for the one that is on the board. Then you would set a delay in order to allow for the propagation and connect an update integer variable block, making sure that the select variable field is configured to the first input. Configure the block to increment the value, and then connect a UART write block and set it to PA10 and add the message to detail the action increase. So with all of this done, it asks the functionality where if you press the button, it'll wait a second, update the integer value, and then write out on PA10 increase. Next, we follow a very similar process for the decrease option. Here, you add in an infinite loop, connect an on button press block, very similar case, except now it is set to pin PA21. This will be for the decrease button. Then for the UART write out option, instead of increase, you can help with writing the decrease action. The last step here is to help modify the condition. So this is the third loop with the compare functionality. So the first thing that would be helpful here is to change the condition of the compare block. Previously, it was different, and now we need to go to A is greater than or equal to B in order to fit exactly what we're looking for here in this system. We have two different conditions that we want to hit with the if-else. If A is greater than or equal to B, we want to have it as a green LED, and then if it is less, we want it to have red. So in this case, we put two different options in the if-else block. So that is simply done by clicking the drop-down button on the if-else block and first selecting the if context. In this case, you can do a LED off block to turn off the red LED, and then an LED on block to turn on the green LED. These are just the two simple options to swap it over. Then, very similar case for the red LED, you can select the else context for the if-else block, and vice versa, what you did with the previous. You will turn the LED off block and configure it to the green LED, and then do the LED on block and configure it to the red LED. So you have two options, and it'll either turn on the red LED or turn on the green LED, depending on the state of the variables. Like I mentioned, this whole project involves three different infinite loops, one for increasing the variable with the first button, one for decreasing the variable with the second button, and one for checking the current status of the variable against the threshold and changing the LEDs accordingly. And once again, within a couple minutes, you've helped to create a working microcontroller firmware. The last case here that we want to work through is an example code for the motor control with pulse width modulation. This specific example controls two different motors using the pulse width modulation initialization blocks, as well as the PWM update duty cycle block to change the speed. In this example, the two outputs are on PA12 and PA13 and are configured to control the motors. There's also a delay block that is used to define some time between the steps in the motor control algorithm. For the first step, we will initialize the PWM. In this case, you have to add in a PWM initialize block and set it outside of the loop. In this case, we set the initialization duty cycle to 0% and set the initialization frequency to kilohertz or 4,000 hertz here, and set the pin to PA12. Then we add a second one for the second motor here, and you're able to do this by clicking on the PWM channel configuration and selecting Create New. You can repeat the same steps for the first block since we'll be doing the same frequency and initial duty cycle there. But the key difference is instead of PA12, it'll be PA13. Lastly, as mentioned, to add the delay in the step in the algorithm, you will add in a delay block and set it for 100 milliseconds. In order to showcase the difference in the control algorithm, we want to update the duty cycle as well. In this case, we can add in an infinite loop after initializing the PWMs. And in this case, you can connect a PWM update duty cycle block. On PWM channel configuration, select the PWM channel 0. Then select the desired duty cycle percent and increase it up to 60. So previously your motors were completely still at 0%, and now they're moving significantly faster up at 60. Then do the same for the second motor here. So PWM update duty cycle block for a second one, and select PWM channel 1. Then also increase the duty cycle to 60. Then you can connect a delay block and set it to 3 seconds for those steps. And in just, once again, a couple minutes, you were able to create a motor control algorithm without writing a single line of code. As mentioned earlier, MSP Zero Code Studio is a visual design environment that simplifies firmware development and is able to make it possible to configure, develop, and run microcontroller applications. No need for any coding and no need for an IDE at all. If you are interested in MSP Zero Code Studio, we have a ton of resources to help you get started today. First, we have a tool page that includes both the downloadable as well as the cloud version of the tool that we mentioned earlier. This is ti.com/tool/MSP Zero Code Studio. We also have an overview of the benefits of Zero Code provided in the linked application brief above. If you are interested in learning more about the MSPM0 portfolio as a whole, I would recommend diving into the linked portfolio overview page and the design and development page. These offer the most comprehensive view of the portfolio and provide steps to get started with evaluating. All of these links along with the slides will be provided after the webinar today, and thank you for taking the time to learn about MSP Zero Code Studio. We will now open up the floor for the Q&A section and hand it over to Owen.
Okay, thanks, Alex, for that great presentation. Looks like we already have several interesting questions, but I want the audience to know that there's still time to submit your questions. Just put them in the Q&A tab there. Okay, Owen, are you with me to answer some questions today?
Yes, I'm here.
Awesome. Okay. First question, as someone with limited program experience, how steep is the learning curve for MSP Zero Code Studio, and what resources are available for beginners to get started with quickly? Yeah, you can answer that verbally. You don't have to type. Oh, I guess I didn't explain that to you.
Oh, okay.
Yeah.
Yeah, I would say that the learning curve is not very steep, considering that it's the blocks are pretty self-explanatory. You know, their function, and at least when you try to connect different blocks together, it makes it pretty clear on what blocks are able to be connected together. There are resources available for beginners to get started quickly. These can be found on the within the application for Zero Code. There's a user's guide and a quick start guide, I believe.
Excellent. Next question. Can you explain how the automatic code generation in MSP Zero Code Studio handles complex time requirements or interrupt priorities that would traditionally require, careful manual programming?
Yeah, so the idea of interrupts isn't exactly presented at like the high level. So
Yeah.
users